Worksheet 11, let's take a look. Find the amplitude, period, phase shift, and the vertical shift, which is just another word for the midline. Then sketch the graph of the function, including 2 full periods. Well, first thing I notice is that this is a negative cosine graph, so I'm just going to do a quick sketch to remind me of what a negative cosine graph would look like. Starting at a min, flipping up to a max, then back down around to a min. So this is negative cosine of x. Its key points occur at its maximum, its 0, minimums here. So now let's find each of these pieces of information that it's looking for. First off, the amplitude, which is the absolute value of my leading coefficient. So in this case it's 3. The period. To find the period, I'm first going to consider the frequency. In order to do that, I have to convert this form of the equation into a more familiar form. To do that, I'm going to factor. So this will be negative 3 cosine. Factor the pi over 4 out, the frequency. Pi over 4 x minus, and when I factor out a pi over 4 from pi, I'd be left with 4. If that's difficult to visualize, think about what would I have to divide pi by. If I also double check this by redistributing my pi over 4, negative 4 times pi over 4, the 4's would cancel out and leave with negative pi, so that does check. From here I can read off my frequency, it's pi over 4. I can now find my period, which is 2 pi over my frequency, which in this case is 2 pi divided by pi over 4, which is equal to 2 pi times 4 over pi multiplied by its reciprocal. Pi's cancel out, and I get a period of 8. On the test, you should also, or even on the homework, you should leave that work there. I'm just limited by my amount of space, so I'm going to erase it. From here, I can now look at my phase shift, or my midline and my phase shift. I'm not adding anything onto this graph, so I will have a midline at 0. So there's no vertical shift. And my phase shift is this value I'm doing to x, which is going to be 4 units. And whenever I have a negative, it's going to be to the right. If I had a positive, it would be to the left. Now that I have all this information, I can start my graph. So I'm going to set up my axes. My x and my y. In order to scale these appropriately, I'm going to have to look at a couple pieces of information. First, I'm going to have to find my key points for the x-axis. Key points occur every quarter of a period, which would be period over 4, which in this case is 8 over 4, which is 2. So I'm going to go every 2 units. Starting at 0, that'd be 0, 2, 4, 6, 8, blah, 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 blah. You can also go back, negative 2, blah, 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 blah. So every 2 units, basically. So 2, 4, 6, 8, which would be 1 full period. And if I want a second period, I can go back, negative 2, negative 4, negative 6, negative 8. For the y-axis, I need to consider the midline and the amplitude. The midline is at 0, okay, and the amplitude needs to go up 3 units and below 3 units from that midline. So I'm going to have to go up 1, 2, 3 units above that midline, and down 1, 2, 3 units below that midline. After that, when I'm going to start graphing this, I'm going to consider my phase shift, which is 4 units to the right, which means I'm going to go to the right 4 units. I'm going to make a dotted line, because that's where my graph will begin to correspond to the beginning of this graph. That's what it means to have shifted. So I've shifted 4 units to the right. So at this point 4, my first point will be the minimum of the graph, which occurs at negative 3. My next point will be at the midline. And my next point will be at its maximum. Right here. Going backwards, it's in the reverse of this. So going back, I'm going back down to my midline, then up to my max, down to the midline, down to my max, down to my min, up to my midline, up to my max. So then when I connect all these points, a smooth curve. There's my graph. I'm going to label it y equals -3 cosine pi over 4 x minus pi. Find the amplitude, the period, the phase shift, and the vertical shift. So this is the same process. Here I have a positive sine graph, so I'm going to do a sketch of that so to remind myself what it looks like. There, first key point is at 0, max, 0, mid, 0. So each of my key points. For here, amplitude is what is in front of the sine. So what may be helpful is to rewrite this in a more standard form. So this is sine of, there's a common factor pi over 2 that I can cancel out, factor out, pi over 2 x minus 1 plus 2. So I've done a quick sketch of what my sine graph should look like, and then I've written it in the standard form of which I'm accustomed to. Then I can read off my amplitude, which is 1, my frequency, which is pi over 2, right here. My period is then 2 pi over my frequency, which is 2 pi over pi over 2, which is 2 pi times 2 over pi, which is 4. So my period is 4. Again, you should leave this work on your page, but I'm going to erase it to give myself more space. What else we have? Midline and phase shift. My midline here, I'm adding 2, so it's going to be at 2. And my phase, which means I've shifted up 2 units. And my phase shift over here is 1 unit right. Remember, negative sign means right shift, positive sign means left shift. So now I'm going to set up my axes. Over here, let's see here. Well, I need to know my key points label my x-axis, so that is every quarter period. So my key points will be period over 4, which is 4 over 4, which is every 1. So go up by ones. 1, 2, 3, 4. That's 1 period. And then I'm going to go -1, -2, -3, -4. So that should be 2 full periods. From here, I'm going to do a dotted line to represent my midline, which is a 2. I'm going to go 1, 2. I have a dotted line here. That's where my middle of my sine graph is going to be. And I'm going to look to my amplitude to see how much more I have to go. So I'm going to have to go at least 1 unit above. So that would be 3. And 1 unit below, which is 1. So that's all I really need. If you want to, you could scale down to complete your y-axis. It's fine. So now, looking at my phase shift, I'm 1 unit right. So I'm going to go 1 unit to the right. So my graph will start. And let's take a look. If we have my sine graph is starting at my midline. So starting at my midline here. My next key point goes up to a maximum. So we'll go to a maximum at 3. 1 unit above 2. Back down to my midline. Down to my minimum. Okay. So there's my, and then, well, that's all I have scaled. If you want to, you can continue to 5. Go back up to here. That's fine. Or if you didn't have to, you could have, once you have that value plotted, then go back. So going backwards through sine. This first point corresponds to this last point. So I'm going to start going backwards, down to a min, up to a midline, up to a max, down to a midline, to here. And when I connect all my points, what I end up with is my graph y equals 2 plus sine pi over 2x minus pi over 2. Sorry, that's a little bit sloppy. And that's my graph. Verifying trig identities. Let's take a look at the first one we need to verify. Okay, whenever I'm verifying a trig identity, I'm going to start by making an impenetrable barrier between these 2 sides because I only want to work with 1 side at a time. I don't want to cross anything over. So, first thing I notice is that on my left, I have things in terms of cotangent and tangent, but on my right, everything is in terms of sine and cosine. So what I'm going to do is convert my left-hand side into sines and cosines. So cotangent is equal to cosine, oops, sorry about that. Cotangent is equal to cosine of x over sine of x. And tangent is equal to sine of x over cosine of x. Well, if I keep change flip, I'm going to multiply by the reciprocal of the denominator. I get cosine of x over sine of x times cosine of x over sine of x, which is just cosine squared x over sine squared x, which looks slightly similar. At least I have things in terms of sines and cosines, but it looks like I'd have to convert my denominator from cosine to sine. So whenever I see a cosine squared and a sine squared, I'm going to think of my Pythagorean identity, sine squared x plus cosine squared x equals 1, which if I manipulate by bringing one term to the other side, I get cosine squared x equals 1 minus sine squared x, and equally true would be sine squared x equals 1 minus cosine squared x. So I can use that identity in here, and I get 1 minus sine squared x over 1 minus cosine squared x, which is exactly what I was trying to show. Okay, let's take a look at the second one. Again, I'm going to make my barrier. Looking at this, I have both terms of tangent and secant on the left, but only a term secant on the right. So maybe I'll see if I can convert those tangents to secants. I'm going to remember, again, my Pythagorean identity, sine squared x plus cosine squared x equals 1. And if I want this in tangents, I'd have to divide everything by cosine squared x. If I divide everything by cosine squared x, I end up with tan squared x plus 1 equals 1 over cosine squared x, which is just secant squared x. So it looks like I can convert tan squared x into secant squared x minus 1. Well, here I have a tan to the fourth, so let me square this. Tan to the fourth x equals secant squared x minus 1 squared. So that's what I'm going to replace tan to the fourth with. Secant squared x minus 1 squared minus secant to the fourth x. Well, when I FOIL this out, I end up with secant to the fourth x minus 2 secant squared x plus 1 minus secant to the fourth x. Well, my secant to the fourth x's cancel out and leave me with 1 minus 2 secant squared x. Okay. This work I would consider all scrap work. I would leave it off to the side. You should include it on your final exam, just to the side of your verification. Okay, let's look at number 3. Again, let's see, I'm going to start with my barrier. And I'm going to inspect this to see what the best course of action is going to be. On my left-hand side, I have both tangents and sines. On my right-hand side, I both have tangents and sines. So maybe that's not going to be the best option. Here I have a subtraction, and here a multiplication. When I'm not really sure how to proceed, I can always go back to my basic form, or my basic strategy, which is just to convert everything in terms of sine and cosine, and see if anything cancels out. I'm going to use my quotient identity on tangent, which is sine over cosine. So tangent squared would be sine squared over cosine squared x minus sine squared x. Okay, this looks kind of promising because now I have a common factor of sine x I can factor out. So I end up with sine squared x, 1 over cosine squared minus 1. Well, 1 over cosine squared has an identity. This would be sine squared x times secant squared x minus 1. And we saw from the last example that tan squared is equal to secant squared x minus 1. It comes from the Pythagorean identity 1 plus tan squared x equals equals secant squared x. In this Pythagorean identity, I can arrive at this equation, which means I can replace this entire term with tan squared. So this is just sine squared x times tan squared x.